Another example of Pythagorean theorem. Again, we're missing a hypotenuse here, so we're trying to find C. So what we're going to do is we're going to write down our formula. This pretty much works every time the same way. So my formula is a squared plus b squared equals c squared. So anytime I've got a right triangle, that's the formula to define Pythagorean theorem. All right, so again, the smaller leg is typically A, so 6 is A, and the longer leg is B. Okay, if you switch those around, that's totally fine. It won't hurt anything. So what we're going to do is we're going to plug in 6 and 8, where A and B are. So we're going to plug in 6 for A, 8 for B, and all of that equals C squared. So remember, when we're talking about squared, we're talking about a number times itself. All right, so 6 squared, 6 times itself is 6 times 6, so that's going to be 36. 8 squared is going to be 8 times 8, which is 64. And all of that still equals C squared. All right, I go ahead and I add here. So 36 plus 64 is 100. That's going to equal C squared. All right, what I'm thinking about to get to C is what times itself gets me to 100. Now, there's an easy way to do this on a calculator, and it'll give you the exact number every time. So what we do is we take the square root of both sides. What that does is that simplifies the square out of it. Okay, so it takes out that square. I'm left with just C, as you see below. And then the square root of 100, okay, that's that radicand, and then the 100 underneath it. That's just saying what times itself gets me to 100. Well, 10 times 10 is 100. So our missing hypotenuse was 10. All right, that's what basic Pythagorean theorem looks like.